I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself in now and then finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me. Isaac Newton. Discovering the legacy of physics' greatest minds. The 17 most important people in the field. Introduction. Physics is a fundamental science that seeks to understand the behavior of the natural world. It has led to some of the most significant scientific discoveries in history, and many of the theories and concepts that physicists have developed have profoundly impacted our daily lives. This impact is mainly due to the brilliant minds who have contributed to the field with their groundbreaking research and theories. In this video, we will look at the 17 most influential people in the history of physics, exploring their key ideas, academic impact, and the legacy they have left on the field. 1. Isaac Newton, 1642–1727, developed the laws of motion and the law of universal gravitation and laid the foundations of modern physics. His work had a profound impact on mathematics, physics, and astronomy. In addition to his work on mechanics and gravitation, Newton made significant contributions to the study of optics. He developed the first theory of color, demonstrating that white light comprises a spectrum of colors. He also designed the reflecting telescope, which is still used in astronomy today. 2. Albert Einstein, 1879–1955, developed the theory of relativity, made significant contributions to quantum mechanics and statistical mechanics, and introduced the concept of energy-mass equivalence. Einstein was awarded the Nobel Prize in Physics in 1921 for his work on the photoelectric effect, which is the phenomenon in which electrons are emitted from a material when exposed to light. Einstein's explanation of the photoelectric effect helped establish the particle-like behavior of light and significantly contributed to the development of quantum mechanics. 3. Galileo Galilei, 1564–1642, made essential discoveries in mechanics and astronomy, including the laws of motion and the phases of Venus. He is also known for his telescopic observation work and his role in the scientific revolution. In 1632, Galileo published a book called Dialogue concerning the two chief world systems, which presented arguments for the solar system's heliocentric, sun-centered model. This book was seen as a direct challenge to the Church's teachings, which held that the Earth was at the center of the universe. Galileo was summoned to Rome to stand trial before the Inquisition. He was forced to renounce his support for the heliocentric model and was placed under house arrest for the remainder of his life. 4. James Clerk Maxwell, 1831–1879, developed the theory of electromagnetism, which describes the behavior of electric and magnetic fields and forms the basis of modern electrical and communication technologies. Maxwell's equations, developed in the mid-19th century, provided a comprehensive description of the behavior of electromagnetic fields, including the nature of light as an electromagnetic wave. This work suggested that the speed of light is constant and does not depend on the observer's motion, which was a departure from classical mechanics and challenged the notion of absolute space and time. This was the primary foundation for Einstein to discover the theory of relativity. 5. Werner Heisenberg, 1901–1976, developed the uncertainty principle and made significant contributions to the development of quantum mechanics, including the matrix mechanics formulation of the theory. Heisenberg's most important contribution to physics is the formulation of matrix mechanics, which he developed in 1925 in collaboration with Max Born and Pascual Jordan. This theory provided a mathematical framework for quantum mechanics and made it possible to calculate the probabilities of certain quantum events. 6. Richard Feynman, 1918–1988, made essential contributions to the fields of quantum mechanics and particle physics and the theory of quantum electrodynamics. He introduced a novel approach to calculating the probabilities of quantum events, now known as Feynman diagrams. This theory describes the behavior of light and matters at the subatomic level. He made significant contributions to the development of quantum electrodynamics, QED. 7. Niels Bohr, 1885–1962, made essential contributions to the development of quantum mechanics, including the Bohr model of the atom and the principle of complementarity. Bohr's model of the atom also played a crucial role in the development of quantum mechanics, a theory that describes the behavior of particles at the atomic and subatomic levels. Bohr's work on quantum mechanics helped explain many of the puzzling phenomena observed in experiments with atoms, including the fact that electrons exist in discrete energy states. 8. Michael Faraday, 1791–1867, made essential discoveries in electromagnetism and electrochemistry, including the laws of electromagnetic induction and the Faraday cage. Faraday's work on electromagnetism was particularly groundbreaking. He discovered electromagnetic induction, the process by which a changing magnetic field generates an electric current in a nearby conductor. This discovery had significant implications for the development of electric power generation and distribution, and it paved the way for the development of many modern electrical technologies. 9. Marie Curie, 1867–1934, made essential radioactivity and nuclear physics discoveries. She was the first woman to win a Nobel Prize and the first person to win 2 Nobel Prizes in different fields. She discovered 2 new elements, polonium and radium, which are highly radioactive and played a vital role in developing X-ray technology during World War I. Still, she and her husband died because they were unaware of the risk of radiation exposure during the experiment. 10. Johannes Kepler, 1571–1630, made essential discoveries in optics and developed the laws of planetary motion. Kepler's laws of planetary motion were crucial in the development of Isaac Newton's theory of gravitation. Which provided a complete explanation of the movement of planets and other objects in space. His work laid the foundation for the development of modern astronomy and astrophysics. 11. Blaise Pascal, 1623–1662, made essential contributions to the fields of hydrodynamics and hydrostatics and developed the concept of pressure. In physics, Pascal made essential contributions to the study of hydrodynamics, including his discovery of the hydraulic press and his work on the nature of atmospheric pressure. He also conducted experiments on the behavior of air, and his work on this subject led to the development of the barometer, which measures atmospheric pressure. 12. William Gilbert, 1544–1603, made essential discoveries in the field of magnetism and developed the Earth's magnetic field concept. Gilbert's most significant contribution to science was his study of magnetism, published in his book De Magnete, on the magnet, in 1600. In this work, Gilbert argued that the Earth itself was a magnet. He developed a systematic method for studying magnetic phenomena, which involved using compasses and observing the behavior of magnetic materials. 13. Leonhard Euler, 1707–1783, made essential contributions to the fields of mechanics and optics and developed the concept of the calculus of variations. Despite losing his eyesight in the later years, Euler continued to work and make significant contributions to mathematics and physics. He is credited with writing over 800 books and papers in his lifetime, and his work continues to influence and inspire mathematicians and scientists today. 14. Paul Dirac, 1902–1984, made essential contributions to the development of quantum mechanics and particle physics, including the prediction of antimatter and the development of the Dirac equation. The Dirac equation is a mathematical formula that describes the behavior of subatomic particles called fermions, which have a property called spin. His work had a profound impact on the development of modern physics. 15. Robert Boyle, 1627–1691, made essential contributions to the fields of thermodynamics and the behavior of gases and is credited with developing Boyle's law, which describes the behavior of gases under pressure. In addition to his work on gases, Boyle also made essential contributions to the study of chemistry, including his work on the nature of acids and bases and his experiments on the effect of temperature on chemical reactions. He also made significant contributions to the study of light and color, and his work in this area helped to lay the foundation for the development of modern optics. 16. Dmitry Mendeleev, 1834–1907, developed the periodic table of elements, widely considered one of chemistry's most important organizing principles. It became commonly accepted in the scientific community and was quickly adopted as a standard tool for organizing elements. His work paved the way for significant advances in the study of atomic structure and chemical reactions, which continues to impact modern science and technology profoundly. 17. Enrico Fermi, 1901–1954, made essential contributions to developing nuclear and particle physics, including creating the first atomic reactor. He also worked on developing the hydrogen bomb, although he had concerns about the dangers of atomic weapons and spoke out against their use. Fermi received numerous honors and awards throughout his career, including the Nobel Prize in Physics in 1938 for his work on discovering new radioactive elements. Conclusion. The 17 people we have looked at in this video are just a few of the many individuals who have contributed to the development of physics over the years. Their work has led to important discoveries and advancements in our understanding of the natural world and has profoundly impacted our daily lives. By exploring their contributions to the field, we gain a greater appreciation for the importance of physics and the many ways it shapes our world. As we continue to learn more about the physical world, it is essential to remember the remarkable individuals who have paved the way for our understanding of it. Thanks for watching.